Alrighty guys, welcome to your page 6, okay? I just want to let you know that you have to practice these informations, because if you just think you can just copy them down, you are not going to do well on this test. You have to see all the scenarios that's given so you can practice these scenarios. Alright, let's look at number 43, okay? On 43, I'm going to highlight each individual term. Here's one, here's another, and then here's another. You guys see all that? I cannot go and cancel logs here because that one doesn't have any logs, so you cannot cancel them out. But what you can do is you can condense. Remember how you learned to rewrite this as one? Okay? They both contain log and they're both on the same side. So I'm going to write log base 5 of 2x squared. What goes with minus divided by 10 is equal to 1. You see that right there? Now that I have this, and you're more than welcome to put parentheses around it, I want to get rid of log. How do you get rid of a log? Well, the inverse is exponent. So observe, where is your base? My base is a 5. To the 1 equal 2x squared divided by 10. Okay? What is 5 to the first power? 5. 2x squared divided by 10. Okay. Now we're going to solve for x squared. What's opposite of dividing? Multiply. What you do to one side, you do to the other side. So 10 times 5 is equal to 50. 50 equals 2x squared. Divide by 2. X squared is equal to 25. Okay? Now you're going to solve for x. Opposite of a square is a square root. Continue right here. So x is equal to plus 5 and negative 5. Two answers. You could write it plus or minus 5, just like that. Okay? Now, always remember to check. So when you check, you can use either one of these. I can't use that one because I don't have an x, but I can use that one. So, log base 5 of 2 times 5 squared. Okay? Type that into your calculator, just like this. Alpha window, number 5. Base is 5, 2. Okay. 2 parentheses, 5 squared. 2 open, 2 close. Okay, I knew that didn't look right. Okay, let me try this again. 5 squared is 25. So alpha window, number 5. Base is 5. 2 parentheses 5 square. Just like that. Get out of it. Okay, there you go. See, I have a whole number, and that works. Now, what if I did it with a negative? Negative 5 parentheses. Okay, they both work. So, this one has 2 answers, and they both work. You can write it like that, or you can write it like that. Okay? Number 44. All right, let's outline what we've got. We have this log, this one has a log, and that one does not. So you are not able to cancel. So you actually have to condense. And I can condense because they're both log base 9 of x. What goes with a plus? Multiplication. See that? Okay. I want to get rid of log, so inverse of that is exponent. So 9 squared is equal to x times x plus 24. 9 squared is 81. X squared is x squared. X times x squared plus 24x. Okay? Now, that's a quadratic. Remember parabolas? Quadratic. So what you want to do is you want to move everything over and set it equal to 0. So that cancel. 0 is equal to x squared plus 24x minus 81. 2 ways you can do this. See if you can factor, and if you can't factor, you have to use the quadratic formula. So I'm going to factor. Factors of x squared is x and x. What 2 numbers multiply to give you negative 81, negative, and it's going to subtract to give you 24x, positive. Okay? All right. So let's take a look. If you don't know your numbers well, you can go to y equal and type 81 divided by x, just like that. Go to your table. Ooh, let me change this real quick to table set, starting at 0, okay? There we go. 1 and 81 do not subtract to be 24. How about 3 and 27? So, 3 and 27. This is plus, so it goes with the bigger number. If this was negative, negative would go with the bigger number. So, negative 3 plus 27. All right, that is factoring. Now, you're not done yet. You have to set each one of this equal to 0. So, x is equal to 3. Set that one equal to 0. X is equal to negative 27. Okay? So those are my two answers. Make sure you check your two answers. You can use this one to check, or you can use this one to check. Now take a look. Log base 9 of x. Can x be a positive number? Absolutely. Check. Can x be a negative 27? No, because you can't have a negative there. So this one does not work. 3 is your only solution for number 44. Okay? All right, let's go to radioactive decay. Here we go. I'm going to move this up a little bit so you can kind of read the whole thing, okay? Find the age of the following objects modeled by exponential decay. And the formula you're going to use is A is equal to P times Euler's number raised to the rate times time. Okay? You find a fossil in your backyard. Oh, by the way, read the directions, please. After testing, it is determined that there is 64% of the original radium-226. How old is your fossils? Radium-226 has a half-life of 1,600 years. All right. Now, you don't know what the rate of radium is. So the first thing you're going to do is you're going to find the R of radium. Okay? So to find that, you know half-life. Well, half-life, what's half of 100%? 50. And that's where that 50 comes from. Base E, don't know what rate is, but the half-life of radium is 1,600. Okay? Now you are going to solve. So there's your formula, and you are going to solve. Divide by 100, divide by 100. So 0.5 is equal to Euler's number raised to the R times 1,600. Solving for R, want to bring it down, so inverse of that is log base E of 0.5 is equal to R times 1,600. Okay. Instead of log base E, I'm going to write natural log equals R times 1,600. Solving for R, divide by 1,600. What you do to one side, you do to the other side. Try to get 4 decimal places, please. Okay, you ready? Natural log, 0.5 parentheses, divided by 1,600. All right, so negative 0.4. Ooh, that was totally wrong. Okay, let me write this correctly. There we go. Negative 4.332. 4 decimal places, please. You guys see that E right there? E is written as times 10 to the negative 4. Box in your rate, because you're going to use that in a little bit. Okay? All right. Now that you know the rate of decay for radium, you can use that to figure out how old the fossil is, because the question is, how old is that fossil? Okay? Well, 64% of it left. A percent is always out of 100. And I'm using radium to figure out how fast it is decaying, and the rate of decay for that is negative 4.3322 times 10 to the negative 4, and I like to put parentheses around mine, times T. T is going to tell me the age of that fossil that has 64% radium. So how do you solve for this? All right. Let me find my blue pen. Okay, you guys ready? So, what are we going to do? Divide by 100, divide by 100. So 0.64 is equal to base E raised to negative 0.43322 times 10 to the negative 4t. Okay? T is in exponent position. I need to use the inverse of exponent, so log. Well, log has a base e, so I'm going to skip that and go to natural log of 0.64 equals negative 4.3322 times 10 to the negative 4t. Okay? Solving for t, divide. What you do to one side, you do to the other side. All right, so that'll give you t. Okay, let me show you how to type this in correctly. This right here. Everyone ready? Natural log 0.64 divided by negative 4.3322. You guys see this times 10? That button is right here. You see that EE, okay? So second E. You see how E comes up? That E represents times 10. Do not raise it to a power. Just put negative E. EE tells you you got the exponent, it's raising it for you. So how old is that fossil? That fossil is 1,030.2 years old. One decimal places would be great for the years, but your rate needs to be 4. There you go. Find the rate, find the time. All right, number 46. You guys ready? You find a fossil on a hiking trip and have it tested in the lab. It is determined to have 19% of its plutonium-238 remaining. How old is the fossil? Like before, we need to find the rate of plutonium's decay. Half-life is 50%. If it says quarter life, this would be 25, okay? Out of 100 times E raised to the R times half-life is 88. Same thing, divided by 100, so 0.50 equals E raised to the R times 88. All right, solving for R, base is E, so natural log of 0.50 equals R times 88. Divide both sides by 88, okay, so R is equal to natural log 0.5 parentheses divided by 88. So the rate of decay for plutonium is negative 0.00788. All right, that's good. Box that in, please. Okay, so 50%, half-life is 88, plutonium's decaying at negative 0.00788, and it's negative because it's a decay. Once you find the rate of it, we can find how old this fossil is, okay? So, what percent of it is left? 19 of plutonium is left, 19% out of 100, decaying at a rate of 0.00788 times T. Divide by 100. So 0.19 is equal to E raised to 0.00788T. Solving for T, my base is in E, so natural log of 0.19 equals negative 0.00788T. Divide both sides by negative 0.00788. What you do to one, you do to the other. So T is equal to natural log 0.19 parentheses divided by negative 0.00788. So the age of the fossil is 2.08 years old. And there you have it. It's not bad at all. Radioactive decay is a two-step process. First find the rate, then find the time. Okay? Good luck, guys. You have got to practice. You can do this. I know you all can. If not, I wouldn't have challenged you. Have a great day.